afternoon, students. Now today we are going to study how the chemical reaction takes place, how to write the chemical reaction and how to balance the chemical reaction. Before that, let's first recall what are the changes took place in the nature. There are the two types of changes. One is known as a physical change and another is known as a chemical change. Physical changes, for example, if there is a change in temperature, those are the physical changes. If the shape is going to be changed, the color is going to be changed, they are all physical changes. For example, if we are going to melt the ice going to melt into the water, then it is a physical change. If we are going to evaporate the water or boil the water gets converted into the water vapor, means it gets converted into the gaseous state. So if the states are going to be changed, then those are the physical changes. Now the next is the chemical changes. Chemical changes are the changes in which the substance are going to be changed completely chemically, and their physical and chemical property both are going to be changed, then those changes are known as a chemical changes. For example, as you know that we used to make the curd from the milk, that change is known as a chemical change. And if we are going to, as we know that the fruit used to ripen, so that changes is also a chemical changes. So there are so many chemical changes took place in our day-to-day life. There is a table in your book. Go through that table and make identify which changes are physical changes and which changes are chemical changes. Now students, as we have studied the various types of chemical reactions, now let's see how to write this chemical reaction in the form of an equation. First of all, we use the symbols for all the elements and we use the formula for the compound. We know all the formulas. Here, let's see some examples. First of all, we are going to write all the chemical which is going to react initially on the left hand side. They are known as a reactant, and on the right hand side they are known as a product. So on the left hand side reactant and on the right hand side product. Now let's see the first example. Here the copper sulfate react with zinc to form zinc sulfate and copper. Okay. So in this equation we have wrote the compound molecular formula. Let's see the other thing which we have wrote. This is AQ means aqueous. Here it is solid. Aqueous and solid means fluid. In the chemical equation we used to write the compound in the form of a formula, as well as we used to write the state also. For example, the copper sulfate is in the aqueous form, so we used to write aqueous. Zinc is in the solid form, so we will write in a bracket S. Then aqueous solution again it is formed, and here the copper solid. And if the heat is liberated, then we used to write the heat also. So in this way, from the chemical reaction we come to know that whether the heat is absorbed or released. In this chemical reaction, heat is released. Let's see one more example. Here calcium carbonate, which is in a solid state, so we will write S. Here this symbol indicates that we are providing the heat, we are heating this, and calcium oxide which is solid, which is going to form, and carbon dioxide gas is formed, so we used to write G, as well as we used to make an arrow. So carbon dioxide gas, moreover this gas is going to move, release, so that's why upward arrow mark we used to mention. Next, let's see one more chemical reaction. Now, let's see one more chemical reaction. Here, in this chemical reaction, sometimes the chemicals are dilute, sometimes the chemicals are concentrated. So, additional information is there. For example, here the nitric acid is used. So, in this nitric acid, Now, in the chemical reaction, some additional information are also mentioned. For example, some acids are dilute as well as concentrated. Then we have to mention that. For example, the copper react with the concentrated nitric acid. Then here we used to write concentrated. In short, we used to write CONC and C also, concentrated. And in case of a dilute, we used to write, and in case, start. In short, we used to write concentrated, and in case of a dilute, we used to write DIL, or in a detail also. So, additional information is, because formula is same for dilute and concentrated. So, to mention whether it is concentrated, we used to write concentrated. So, here copper react with the concentrated nitric acid to form copper nitrate in aqueous form, so AQ. Then nitrogen dioxide gaseous state and the water which is in a liquid state. So, in this way we mention the information in the chemical equation. If we are going to take dilute, then some other compound is going to form. Sodium nitric oxide is going to form. Now, sometimes in a chemical reaction, sometimes the general words are also used instead of the whole chemical formula. For example, one is vegetable oil. If it is going to react with the hydrogen gas, then we use to write the name also. Okay. Apart from that, sometimes we used to heat it at a particular temperature. We need a catalyst also. So, in the chemical reaction, we also mention that here it is heated for 60 degrees Celsius, and the catalyst which is used is nickel catalyst. So, we write over the arrow that it is nickel catalyst and 60 degree temperature. And what happened? Vanaspati ghee is going to form. So, the general name of the compound is we used to write here, which is in the form of a solid. So, to generalize the chemical reaction, sometimes but this is not a proper chemical equation. This is just for an information, so that we get a general. This is a general chemical equation. But yes, we used to write this information that at what degree it is heated, which catalyst is used in any one of the chemical reactions. So, in this way, we used to write the chemical equation, and from the chemical equation, we used to get all the information regarding the chemical reaction. Now, students, let's study how to balance a given chemical reaction or an equation. First of all, let's see with the help of an example that suppose a sodium hydroxide react with the sulfuric acid. Then we will write the reaction in a form of a chemical equation in this way. Let's see. Sodium hydroxide NaOH when react with sulfuric acid H2SO4, then it is going to form sodium sulfate, Na2SO4 and water H2O. So this is a basic chemical equation or a reaction. Now we have to balance this. For that, what we are going to do, first of all, make a table or a chart like this. Draw a chart in this way. In this chart, what we have to write first? First, write down the elements. Then, write down the reactant which is on the left hand side and the product which is on the right hand side. Now, we are going to write the symbols of the elements. Which are the elements are present in this chemical reaction? Sodium, oxygen, hydrogen and sulfur. So these are the elements present in the chemical reaction. Now on left hand side, means on the reactant side, we are going to find out the total number of elements present in atoms present in on the left hand side. Let's see. First of all, sodium. Here there is only one atom of sodium. So we will write 1. Then we are going to count the total atoms of oxygen. So here it is 1, here it is 4. So 4 plus 1, 5. So 5 atoms of oxygen. Then hydrogen, total 1, 2, 3. So there are 3 atoms of hydrogen on left hand side. Sulfur, there is 1 atom of sulfur. So 1. So in this way, we are going to write all the atoms of the hydrogen present on the left hand side or on the reactant side. Now on the product side, same elements, we will count the number of atoms. Sodium, there are 2, so we will write 2. Now the next is oxygen. Here it is 4, 4 plus 1, 5. Now the next is hydrogen. Here hydrogen, 2 atoms of hydrogen, so we will write 2. Now the sulfur is 1, we will write 1. So in this way, we will write all the number of atoms in reactant and product. Now check whether the atoms are equal or balanced on both the side or not. Let's see. Sodium, here it is 1, here it is 2. So it is not balanced. Oxygen it is balanced. Hydrogen 3 and 2 not balanced. Sulfur it is balanced. So we can say from this chart we can say that all the elements, the number of atoms of the elements are not balanced on the left hand side and the right hand side, or they are not equal. So from this table we come to know that the equation is not balanced. So what are the steps? What is the first step to balance the chemical equation? The first step is to choose the compound which is having the maximum number of atoms. So here the first one is both are of same number of atoms. Let's see the first one. Here there are 1, 2, 3. 3 elements are present in the compound. Here also 3 elements are present in the compound. So here it is easy to take the sodium because sodium is unbalanced here. So sodium hydroxide, we will take sodium hydroxide. First we will balance that. And for that again we have to make a table or a chart. Let's see here. So in this chart what you have to do? You have to write the number of sodium atoms. Then on the reactant side how many sodium atoms are there, and on the product side how many atoms are there. So initially in the reactant side, in sodium hydroxide the number of atoms of the sodium are 1, is only 1. Now on the right hand side, means on the product side, the compound of the sodium is now sodium sulfate, Na2SO4. So here the number of atoms of sodium is 2. So we write 1 and 2 here. Now the next one is, now 1 and the 2 are the numbers. What you will do to balance these two mathematical numbers? Let's see. If we multiply this 1 by 2, we will get 2. And on here it is 2. So what we have to do? We have to multiply it by 2, then both the side it will get the same number. It will become balanced. So that means we have to write 2 in front of the sodium hydroxide. So let's see our initial chemical reaction. This is our chemical equation. In this chemical equation, we are going to put a 2 here. If we are going to put 2, then only sodium atom. 2 sodium atoms are here, and on the product side 2 sodium atoms are here. So the sodium atoms are balanced. So what we have done, we have put a 2 in front of the sodium hydroxide. Now let's see. Again we are going to make a table in this way and check now how many atoms are get balanced and how many atoms are unbalanced. So first of all, sodium on left hand side, it is 2. So we will write 2. On right hand side it is 2. Just now we are balanced. Second is oxygen. Here the oxygen are 2. Here it is 4. So 4 plus 2, 6. So on reactant left hand side 6 atoms of oxygen. Now let's see on the right hand side. This is 4 plus 1 makes 5. On right hand side 5 atoms of oxygen. Now we'll check the number of hydrogen atoms. Hydrogen atoms are 2 plus 2, 4 on the left hand side, and on the right hand side there are 2 hydrogen atoms. Now we'll check the number of sulfur. Here it is 1, on right hand side also it is 1. So in this way again we'll do this table. Check the table. We can see that the oxygen and hydrogen both are still unbalanced. So again we have to balance the equation. For that, now what we will do, we are going to choose the another compound. Now which compound we are going to choose? Which is easier one? Just check. यहाँ पर कौन सा easy हो रहा है? यहाँ पर देखो ऑक्सीजन की 6 है, यहाँ पर 5 है. दोनों में कोई कॉमन फैक्टर नहीं है. हाइड्रोजन में 4 और यहाँ पर 2. So 4 and 2 it is easy to balance this 4 and 2 mathematically. So which compound we are going to choose? The compound which contain hydrogen atoms. So which compound we are going to take? The compound contain hydrogen. Here in the chemical reaction there are 2 compounds, sodium hydroxide and sulfuric acid. Here both hydrogen is present. So again we will make a table. First we will write the number of atoms of hydrogen on number of reactant as well as on the product side. So on the reactant side the compounds are NaOH, sodium hydroxide and H2SO4. In the product side, only one compound is there where hydrogen is present, that is H2O, means water. Now, we will count the number of hydrogen atom in the case of the reactant side. This is the initial chemical reaction in which we have put 2 balanced sodium. Then now we will count. Here are 2 hydrogen atoms and 2 plus 2, 4, and here only 2 hydrogen atoms. So this is the initial stage. Now, what we will do to balance this? This is 4. This is 2. And we know that 2 into 2 is 4. So if we multiply with 2, that means where? If we put in front of the water 2, then the hydrogen is going to get balanced. Let's see. This is the second step, the equation which we get from the second step. Now what we will do? We will put the 2 in front of the water. Okay. Now after writing 2 in front of the water, let's again check whether the equation is balanced or not with the help of the table. You can write the table, otherwise directly also you can check whether it is balanced or not. So since the table is here, we are going to take the help of the table. First of all, sodium. Here the sodium are on the left hand side 2, here it is also 2. So 2 and 2. Now we will check the oxygen. Oxygen is 2 plus 4, 6. Here 4 and now oxygen are 2. So 4 plus 2, 6. Next atom is hydrogen. Element is hydrogen. Hydrogen is 2 plus 2, it is 4. On left hand side it is 4. Let's see on the right hand side. 2 into 2, 4. So this is also 4. Now the last element is sulfur. Sulfur 1 and 1. So sulfur left hand side, right hand side 1. So here you can see finally the atoms on left hand side and on the right hand side, this reactant and product, all the elements and the atoms are completely balanced. 2, 2, 6, 6, 4, 4 and 1, 1. So in this way, our given chemical reaction is going to be balanced in this manner. So in this way, we have to balance the rest of the chemical reactions.